Divided by radius gives you... You know what? Let's go have some fun.
Rotational motion exists all around us, from bacteria that use their toes to swim to the fact that we wouldn't exist on Earth without the Earth's rotation. These things are applied to everyday things in life, such as turning ballerinas and wheels. But in order to comprehend and appreciate the use of these, you should see how they are applied in everyday life. So what better way to study rotational motion and have fun than at the amusement park?
The big wheel is a perfect circle. We know that 1 radian is equivalent to 57.3 degrees, since it is when the arc length and the radius are equal in length. We can calculate this using our formula in our magic triangle, by using the circumference of the circle and its revolutional angle. If we want the amount of rad, we cover theta, so we need to divide arc length by radius, or if we want the arc length, we multiply the two below. Doubting it? No. This ride moves at a certain angular velocity, but starts with an angular acceleration to get to that speed. Wait, what is angular velocity and angular acceleration? Angular velocity is the angle curved out each unit of time, as well as its direction shown as the tangent to the curve. This is defined using the following equation. Angular velocity is equal to the radians over the time. The coaster must speed down an incline to gain enough speed by angular acceleration. We define the average angular acceleration as the change in angular velocity per time interval. We see the average angular acceleration is equal to angular velocity over time. However, when we approach the constant speed, we can explain it using Newton's laws. First law states that it should have zero resultant force to continue in a straight line, but not a curve. Therefore, a centripetal acceleration is required to pull into the circle by an additional force called centripetal force. We can now find the exact value of the centripetal force and acceleration by the equation on our illustrating board. But first, Newton's second law states that force, mass and acceleration are related, giving force equals to mass times acceleration. The R represents the reaction force from the seat. If we are on top, the equation is given as, and if we are down, the equation is also shown.
Adventure!